Right, okay, so number 11. Does anyone need me to do any bit of number 11? We're all okay? Right, 12. I did 12 yesterday, didn't I? Are we okay? Does anyone need it done again? Right, and I said leave out 13. So 14, anyone need 14? Yeah, right, okay. So 14 says solve, right? Okay, so it's z squared minus 4z plus 13 equals 0. Okay, so when it says solve and there's a square term, right, what do we know we have to use? Minus b formula, plus or minus the square root of b squared minus 4ac all over 2 times a. But we know the answer is going to be imaginary. How do you know by looking at it the answer is going to be imaginary? Because they use what letter? Z. They use Z instead of X, right? Okay, or Y, or A, or B, right? If they use Z, it's imaginary, right? So A is a number in front of Z squared. So what's A? 1. B is a number in front of Z? Minus 4. And C is a number by itself? 13. So then you fill in. So it's minus 4, okay, plus minus the square root of b squared is minus 4 to b squared minus 4 multiplied by a is 1 multiplied by c is 13, right? All over 2 times a, which is 2 times 1. So minus 4 is a plus. Now you can't put the whole lot. You have to recognize from the start that it's going to be imaginary, because normally we put the whole lot into our calculator, and if you put the whole lot into your calculator, because the answer is an imaginary number, you'll get an error message. Calculator doesn't do imaginary numbers. So you have to do what's underneath the square root sign, right, in the calculator first, okay? So don't put in the square root sign, because the calculator can't get a square root of a negative number. So just what's underneath the square root of the negative number. And I think when you do that, you'll get minus 49. Do you? Yeah. And underneath 2 ones are 2.
I got minus 36.
Minus 36, right, okay, because 4 13s are 52. No, you're right, I'm wrong. That doesn't get said often. It's recorded. The bit where I said I'm wrong. Don't ever show that to my husband. Right, okay. So the square root of minus 36, so you need to take that out to the side. Square root of minus 36. So you can write that as the square root of 36 multiplied by the square root of minus 1. Square root of 36 is what? And what do we write the square root of minus 1 as? I. So instead of the square root of minus 36, I write 6i. So it's 4 plus minus 6i over 2. So that's, each one is divided by 2. So it's 4 over 2 plus minus 6i over 2. So 4 divided by 2 is 2 plus minus 6i divided by 2 is 3i. So one answer is 2 plus 3i, and the other answer is 2 minus 3i. Okay, do you have to separate them? Not at all. Okay, but that's what the plus minus means. Hello.
How do you know when to do that and not the actual minus b formula?
Z. They use Z as the letter. Okay, so it's Z in here. They'd never use Z unless it's imaginary numbers. If they use X, Y, A, B, C, any other letter, but if they use Z, you know it's imaginary, right? Okay, they wouldn't use Z otherwise. Okay, right? Are we okay? Right, that's number 14. Does anyone need number 15?
Yes, please.
Right, okay. So number 15 reads, 15 reads Z1 equals 2 minus 4i, Z2 equals minus 4 plus 2i. So it says plot both on an Argand diagram. So I need to go across 1, 2, and I need to go minus 1, minus 2, minus 3, minus 4, Okay, and I need to go minus 1, minus 2, minus 3, minus 4, and I need to go 1, 2. That'll do me. Okay, so the first one is you go across to 2 on the, remember this is the real axis, this is the imaginary axis. So it's 2 on the real axis and minus 4 on the imaginary axis. So across 2 down to minus 4, there's Z1. Okay, and then the other one is across to minus 4 on the real axis and up 2. So across to minus 4 and up 2, so that would be Z2. Is that okay?
Yeah.
Right, and then the second bit says find Z1 with 2 straight lines either side. What's that? What's that? Modulus. Okay, so 2 straight lines either side is the modulus. So it's the square root of a squared plus b squared. So that's the square root of a squared is the real bit, which is 2 to be squared. B is the number in front of I. Don't take the I. It's just the number in front of I, which is minus 4 to be squared. Into the calculator with that, that'll be 4 plus 16 square root of 20. Calculator is going to 2 root 5 out at you. Is that okay? Right, that's what the calculator is spit out at you. Right, okay. And then they also asked me for Z2 with 2 straight lines either side. Right, okay. So that would be the square root of a squared plus b squared again. This time a is minus 4. So it's minus 4 to be squared plus b is 2. Remember, don't take the I, it's just the number in front of the I. So that would be the square root, that would be 2 root 5 again if you put it into a calculator. Okay? Is that right? Okay, and then the last bit of that is write down 2 other complex numbers that have the same moduli as Z1. Right? If you look, the answers are, the numbers they use are 2 and 4. And it might be a plus 2 or it might be a minus 2. It might be a plus 4 or a minus 4. Doesn't it? Because it doesn't matter, right? Okay, when as long as, because you're going squaring them. Okay? So another one would be minus 2 plus 4i. Another one would be minus 2 minus 4i. See the same numbers. So when you square them, you'll get the same. It could be 4 minus 2i, it could be 4 plus 2i, or it could be minus 4 minus 2i. They're all the possible answers there. Okay? Is that alright? So don't worry about that. Okay, that's pretty advanced. We'll worry about the advanced next year. Okay, we'll get the basics this year and we'll build on it next year. Okay? So if that doesn't make sense to you, don't worry about it. Okay? Are we all alright? Okay, that was number 15. Number 16. Anyone? No? Yes? Okay. 17? Yeah, right, okay. All of it? Yeah, okay. So 17 says, right, if Z1 is equal to 2 plus 3i, and Z2 is equal to 5 minus I, it says find A is Z1 plus Z2. So that's just a case of adding them. Okay, you could put them into brackets if you want, but I might just put them into brackets just to get in the habit of putting them into brackets, because it's not going to make a difference here, but it would make a difference if that was a minus. So the brackets are optional here. Okay, so just drop the brackets and it's the exact same thing. Plus 5 minus I. Put the real bits together. The real bits are 2 and 5 makes 7. And the imaginary bits is plus 3i, and this is minus 1i. So plus 3i minus 1i would be plus 2i. Okay, is that alright? Okay, then B is Z1 minus Z2. Now this is where the brackets are important. So Z1 minus Z2. So Z1 is 2 plus 3i. There's a minus in the middle. Z2 is 5 minus I. Remember, when there's a minus in front of the bracket, all the signs inside the bracket change. So this is the same, 2 plus 3i. This becomes minus 5, and a minus by a minus is a plus and I. Okay, real bits together, so 2 take away 5 is minus 3, and plus 3i plus 1i is plus 4i. Okay, right, so it's very important to put the brackets in if there's a minus, not so important if there's a plus. Okay, right, then it says investigate if the modulus of Z1 plus Z2, so that's the modulus, is equal to the modulus of Z1 minus Z2. So basically, we have the answer to Z1 plus Z2, so they want you to get the modulus of that. And then they want you to get the modulus of this one, because that's Z1 minus Z2, so you just get the modulus of your two answers. So remember, modulus is the square root of a squared plus b squared, no i's. Okay, so that's the square root of 7 to b squared plus 2 to b squared into the calculator with that, and you'll get the square root of 53, right? And over here, does that equal to the modulus of this one? So the modulus of this one is the square root of minus 3 to b squared plus 4 to b squared into the calculator with that, and you'll get 5. Okay, and the answer is, it said investigate if they're the same, and the answer is no, they're not the same. Okay, right, so make sure you answer the question. They said investigate if it's true, and no, it's not true. Right, so you can write false or whatever, I don't care what you write, but just indicate that you know. Right, oh, it's greater than. Right, indicate, sorry, it didn't say equals, it said indicate, investigate if that's greater than that. Okay, it's hard to compare a square root sign with that, so if you turn that into a decimal, it'll be 7 point blah blah blah, right? And question is 7 point something greater than 5, answer is yes. So please ignore everything I just said a minute ago, because I thought it was equals, but it's greater than. Is that alright? Okay, so yes. 18, am I doing 18? Right, okay. So 18 is W is equal to 3 minus 4i, and then it says solve x plus W equals 3yi. So I know what W is, it's 3 minus 4i, so it's x plus 3, that's a plus, so I don't need to bother with brackets. So 3 plus 4i equals 3yi. There's x's and y's in there, and they're asking me to solve. So you pick out the real bits. On the left, let them equal to the real bits. On the right, you pick out the imaginary bits on the left equal to the imaginary bits on the right. So real bits on the left, what have we got? X plus 3 equals real bits on the right. There isn't any, so what you write down? 0, right? Okay, solve that. X equals, bring over the 3, becomes a minus 3. Done, right? Pick out your imaginary bits on the left. So you have minus 4i equals 3yi. Knock off the i's, so you'll get minus 4 equals 3y. Swap it around, minus 3y equals plus 4. Divide by minus 3. You can work it out backwards if you want, okay, or just rearrange it. Y equals 4 over minus 3 is just minus 4 over 3, or you can leave it as 4 over minus 3 is the same thing, as long as the minus is there somewhere. Okay, are we all right? Okay, that was number 18, and the last one was number 19. Number 19, am I doing it? Anyone? No? Right, okay, so I'm going to stop recording.